Hi everyone, welcome back to my videos. I like to solve some geometry problems that were given on a math competition for high school students. This is for grade 11, so junior year of high school. So let's take a look at these problems, and I draw these problems from um, the medium to harder problems on the test. So let's take a look at this first problem here. So small square with side length A, so we see this small square here, and then we have this larger square with side length B. And we want to find the area of the shaded triangle. And you can see the shaded triangle right here. So what I've done is I've labeled these points D, E, F, B, C, G, and E, and what I'm going to do is I'm going to extend segment DF and I'm going to extend segment BC, and they're going to intersect at point A. Then I'm going to use the additive property of area. So area of this big triangle ACF is going to be equal to the area of triangle DEF plus the area of triangle BEC plus the area of triangle EFC plus the area of rectangle ABDE. So triangle DEF is shaded in green, triangle BEC is shaded in red. So we know that triangle ACF, triangle DEF, and triangle BED are right triangles, right? Angle D here is a right angle because, this is the smaller square, right? And a square has 4 right angles. Angle B is also a right angle because that's the bigger square, right? And same reason, a square has 4 right angles, and angle A is also a right angle. I won't get into that, but you can use properties of parallelism and perpendicular lines to kind of prove that this is going to be a right angle. But let's just simplify things and find the area of triangle DEF, which is the area of this green shaded triangle. So it's going to be 1/2 times the length of DE times the length of DF. And we know that length of DF and length of DE are equal to A. So we get 1/2 times A squared. The length of triangle BEC is going to be equal to 1/2 times the length of segment BE times the length of segment BC, which is 1/2 times B. And the length of BE is going to be B minus A, right? The area of triangle ACF, this bigger triangle, is going to be 1/2 times the length of AF times the length of AC. So length of AF is equal to the length of CG, which is B, and the length of AC is going to be equal to A plus B, right? We're adding the length of the smaller square plus the length of the larger square. And so we get 1/2 times B plus A. And the area of rectangle ABDE is equal to the length of AD times the length of AB. And the length of AB is going to be the same as the length of the side of the smaller square, which is A, times the length of AD, which is equal to the length of BE, which we showed was B minus A. So we get A times B minus A. So the next part, we use, this equation here to find the area of triangle EFC, right? So area of triangle EFC is equal to area of triangle ACF minus area of triangle BEC minus area of triangle DEF minus area of rectangle ABDE. So we just substitute the values that we found. We do some algebra, we simplify, we find that area of triangle EFC is equal to A squared divided by 2. So the area of the shaded region, the triangular shaded region, is A squared divided by 2. So I'm going to do one more problem. So we're given a square ABCD with side length S. We're given this path DEFB. We're given that angle F and angle E are right angles, and we're given the length of DE equals 5, the length of EF equals 1, and the length of FB is equal to 2. And we're going to find an exact value for S, which is the length of the side of the square ABCD, right? So let's see how we do this. So write down what we know, and since angle F and angle E are both right angles, they're congruent, right? All right angles are congruent, but I'll just write that as a given. So we're going to draw segment BD, which is a diagonal of this square in red. And we're going to see that diagonal BD intersects the segment EF at point G, which is really hard to see, but you'll have to take a close look at this picture. But the first thing we know is that, so if we look at this angle, not to get confused with the angle F, but this angle G, so angle FGB and angle EGD are vertical angles, and therefore they are congruent. And therefore, from property 5 and property 7, we know that triangle BFG and triangle DEG are similar. We know by the betweenness property of segments, length of FG plus length of GE is equal to 1, therefore length of GE equals 1 minus length of FG. Using the similarity property we've just shown, we know the length of BF divided by length of DE is equal to length of BG divided by length of DG, right? And we know that because lengths of corresponding sides are proportional in similar triangles. So we get length of BG divided by length of DG is equal to 2/5. And we know that because length of BF is 2 and length of DE is equal to 5. So length of BG is equal to 2 divided by 5 times length of DG. We know by the betweenness property of segments that length of BD is equal to length of BG plus the length of GD. And BD is equal to 2/5 times GD, right, which we got from statement 11, plus length of GD, so that's equal to 7 divided by 5 times GD. Again, following from this kind of like similar triangles thing in statement 5 and statement 7, we get FG divided by EG is equal to BF divided by DE. And we know that EG, which is also equal to GE, is equal to 1 minus FG. So we have FG divided by 1 minus FG equals 2/5. And if we solve this using algebra, we get FG is equal to 2 divided by 7. Therefore, EG, which is 1 minus FG, is equal to 1 minus 2/7, which is equal to 5/7. Now, we know that DEG is going to be a right triangle, right? Because angle E is a right angle, and a triangle that contains a right angle is a right triangle. So we can use the Pythagorean theorem. We get length of DG is equal to the square root of length of DE squared plus length of GE squared. Now we can substitute what we know about DE, which is GE equals 5, and we know that GE equals EG equals 5/7. So if we substitute and simplify, we get DG is equal to 15 times the square root of 10 divided by 7. And therefore, since BD is equal to 7 divided by 5 times GD by statement 13, we know that BD is equal to 7 divided by 5 times this value here. And if we simplify, we get 3 times the square root of 10 for this diagonal BD. So we know that all squares have four congruent sides, right? So by the definition of segment congruence, the length of DC equals the length of BC. So, and since we have a right angle at C, this thing's going to be a 45, 45, 90-degree triangle. So, and we know that the lengths of the sides of a 45, 45, 90-degree triangle are in a 1 square root of 2 ratio. So therefore, the length of side ABCD is going to be equal to BD divided by square root of 2. And if we simplify, we get S is equal to 3 times the square root of 5. So the length of the side of the square is going to be 3 times the square root of 5. So I want to thank you for watching this video. I will make other videos containing problems like this. So I hope you enjoyed watching these videos, and please feel free to go over them and do them over again. These are really hard problems because they're taken from math competitions. So they're definitely very challenging, but they're very fun at the same time. So yeah, so I hope everyone has a good night, and I hope to see you soon. All right, bye.